Transformation of trigonometric functions. I'm Anil Kumar, and in this video we'll start with a very basic and important criteria, that is effect of horizontal stretch or compression. Question before us is, what is the effect of horizontal stretch by a factor of 2 on the equation and graph of trigonometric function? Now find students really struggling with understanding horizontal stretch and compression, and that is the reason why I have taken it up. Now when we say trigonometric functions, we normally mean sine, but I'll take example for sine, cosine and tan function in this particular case so that you really understand what we are trying to do. Now when we say sine function, then that means we are looking for a graph which is kind of like this. So I'll make very rough sketches. The idea is to make you understand the concept. This is the cosine function for me, okay, and then we have a tan function which is kind of like this. Okay, now I'd like you to pause the video, answer the question while I make all these sketches here, right? Now the first one, as you know, is the sine function, right? Let's say sine x. So where the x values are 0, pi and 2 pi, right? So we are working in radians at present, pi, and this value here is 2 pi. So the value here is pi plus here pi by 2. Let me write these values also, 3 pi by 2, right? Now in this particular case, as you know, the time period for a tan function is pi, not 2 pi, as it is in the case of sine and cosine. Tan x will actually repeat after every pi radians. So what we really see here, this is minus pi by 2 to pi by 2. So I've taken tan function which is within minus pi by 2 and pi by 2, correct? And that is the cos function. Now the question here is, what is the effect of horizontal stretch by a factor of 2? Now in this particular case, I have not really given you enough room to sketch twice the length. So what I will do here is, I will do for these two functions here, I don't have much room here, so I'll leave cosine for you as an exercise, okay? When we say horizontal stretch, it really means what? It means that every point on the function will horizontally get stretched. So in this particular case, for sine and cosine, we know the amplitude is 1, so it is from minus 1 to plus 1. This is also from 1 to minus 1, right? And here let me just say 1 and minus 1 here. It goes from minus infinity to plus infinity, correct? Now when I say horizontally stretched by a factor of 2, it really means that every point gets multiplied by 2 horizontally. So 0, when you multiply by 2, it remains here itself. Do you see that? But if this point, if I multiply this by 2, it is at pi by 2 now, correct? So pi by 2 times 2 will bring it here. So this point gets stretched and it comes at this position, correct? So the maximum for sine will now occur not at pi by 2 but at pi. And this 0, which is at pi, gets stretched further and it will appear at this point, which is 2 pi. So what we get here is basically a transformed horizontally stretched sine function, which will be kind of like this. Do you see that? You only get half the wave, right? You get only half the wave within a time period of 2 pi. If I consider other points, which this one is 3 pi by 2, let me write, doesn't matter, let me write in this ink, 3 pi by 2. If I multiply this by 2, that is horizontally stretched by a factor of 2, I have to multiply all horizontal values by 2, vertical values remaining same. That's the whole idea. So it will be actually at 3 pi. So let me extend okay? So this is 2 pi. So let us say this is another pi, and Okay, the other one will go further away. So what really happens here is that this part, which is at 3 pi by 2, will appear at 3 pi. So pi, and let's say this is 3 pi for us. So it appears there. So our graph will go like this. Do you understand? And the 0, instead of 2 pi, will be at 2 times 2 pi, and let's say this is 4 pi for us. So like this. Do you get my point, right? So I'm writing 4 pi for this particular graph. So basically our stretch sine function will be kind of shown here, right? Like this. So when I say horizontal stretch, then what really happens here is that the time period instead of 2 pi becomes 4 pi. So horizontal stretch by 2 means time period becomes 4 pi, not 2 pi. If time period is 4 pi, then what is the value of k? K is 2 pi by t, so it will be 2 pi by time period now. One full cycle is not 2 pi but 4 pi. So it will be 2 pi by 4 pi, which is equals to half. Do you see that? If k value is half, then my transformed sine function will be what? My transformed sine function will be sine of half x. Do you see that? So the effect of horizontal stretch by a factor of 2 really is that the k value becomes half. Do you see that? That is on the equation. And as far as the graph is concerned, it stretches. You see only half the wave within 0 to 2 pi and one full wave in 0 to 4 pi. So that is the effect, correct? So following the same logic, what will happen here? If I horizontally stretch it, it will become cos of half x. Do you see that? And all these things will stretch and we'll get only half wave within 0 to 2 pi. That means this point stretches to 2 pi. Do you see that? Right? Pi by 2 stretches to pi. So the graph will be kind of this. Do you see that? Half of cosine wave will appear up to 2 pi and then rest half next to pi, bringing the time period to 4 pi, k value as half. So the equation will get transformed from sine x cosine x in this time to cos of half x. Do you understand? In the case of tan function, horizontally if I am multiplying every value by 2, 0 remains at 0 and these vertical asymptotes will now be not at minus pi by 2, but they will now be at, let me use a different thing, at minus pi and at pi. Do you see that? And the transformed function for me will be kind of every point stretching twice. Do you see that? So it will be kind of like this. Do you understand? And the equation will be tan of half x, right? So in general, if we are stretching by a factor of 2 horizontally, in that case we are looking for a function like sine of half x or cos of half x or tan of half x. Do you understand? That is what I want to emphasize in this particular video. I hope it is very clear algebraically and graphically what is the effect of horizontal stretch. Remember, the y values are not changing. The range of the function does not change. The shape stretches horizontally only. So that is how it should look like. Thank you.